Ok, ok. Ok, ok em, ngủ đi. Có khi lát anh ngủ luôn á chứ. Hello anh. Hello sir.
Hello, I was on mute, sorry.
Yes sir, hello sir.
Hello, Nam. Hello,
Hello, hello.
Mon. Hello,
Hello, Mon.
Trung. Hello, man.
Yeah, hello,
So,
Sian.
how
Yeah,
was your holidays?
yeah, it's really fun sir. We spend a
Yeah,
lot.
it's really fun.
Mhm. So, it was a lunar new year for you, right?
Yes, it's a Lunar New Year.
Okay. Hi, Dad.
Hello, sir.
So, we are waiting for some more people to join. Then we will start.
No, no, most of them busy sir. I think busy rest week.
Okay. So, only you people will join, right? Okay. I'll
Yes sir,
ping
we
in
can
the
start
group.
now.
Attendance. Okay. So, have you got some time to review that document that I sent you, or have you went through some SOC document, anything, so that I
Sorry,
can?
sir. Last 3 day, I was enjoy the holiday, so I will
Okay,
start to review it from today and so to the rest of the week.
okay, okay, Nam. So what I am planning? Okay, so after today class, we will be having some mock interviews as well. Okay. So mock interview I will be asking you about what you had done, what is your understanding. I'll ask you some questions as well. Okay.
Yes, sir.
So be prepared for from tomorrow. We will have half an hour of question answer session and half an hour of the class or 45 minutes of class. Okay, sounds good.
For
sir.
each person or for single person, sir?
Okay.
You mean the mock interview for single person?
Mock interview means I will ask them questions, combined question, not for a single person. Later on, we will start with a single person as well. Okay.
Yeah. Okay, sir. Okay, sir.
We will do it that way. So you will get an idea of what questions they are asking. Okay. Then later this week, I will share your CVs as well. Okay. On what projects you had worked on and what is the projects we are showing it to customer that you had worked on these kind of projects. Okay. So you should be well aware about it, and we will be having some mock interviews on that as well. Got it? Okay, guys. So
Yes, sir.
okay, so let's start. Any questions? Anything you haven't understood from last week? So I will share my screen then. Okay, guys. Okay, guys. So we have studied about introduction to SOC. This is clear to you? Basic SOC architecture, AMBA protocol, mass, verification flow, address map. I think address map is quite clear to you, right? All the register access, IO muxing, interrupt, DMA, error response. This everything is clear for you. Okay, so let's start with this. This is a very small topic that I will cover. Verification using models for analog macros at SOC level. Okay. So, okay. Do you guys know what is a PLL? Do you guys know what is a PLL?
File log loop, sir.
Phase lock loop, right? So why it is used for?
It's used to fix the frequency inside the memory, to fix the clock, to provide the clock.
Analog modules, great. So
Yeah.
basically, it's used for generating the clock. Okay, since it's an analog module, in simulation we have a Verilog module of it. Okay, so in simulation or RTL, we use a Verilog model. Okay, we use a Verilog model of PLLs. You guys have heard about thermal sensors? You guys
Can
have
you repeat, sir?
thermal sensors, temperature sensors inside the SOC.
Yeah, I see inside the spec, but I don't know it, sir.
Okay, so basically thermal sensors and temperature sensors, they used to continuously monitor the temperature of a chip. Okay, so you guys know which is the most power consuming thing or signal inside any circuit? Which is the most power consuming thing inside a circuit that will consume most of the power?
Register, sir.
No, not the register. Signal I'm talking about, clock. Clock is the one that consumes most of the power because it always toggles from 01010101, right? So the most power consuming things inside a circuit is a clock. Got it? And on what signal the speed of the circuit depends? On what signal the speed of the circuit depends? Clock, correct? So if the clock is higher, your circuit will be faster. Got it?
Yes, sir.
So if your megahertz circuit 2 is working on 2 gigahertz, which circuit is faster? One circuit is working on 500 megahertz, second circuit is working on 2 gigahertz. Which is faster?
2 gigahertz.
2 gigahertz, because the frequency is higher, correct? But as I told you, which circuit will consume more power? Circuit 1 with 500 megahertz clock frequency or circuit 2 with 2 gigahertz clock frequency?
One, sir, because it stay one for longer, in longer.
Yeah, so circuit 1 will consume less power. So you see, if you are increasing the speed, power consumption is getting increased, right? So shall I write it over here? Speed increase, then what will increase? Power consumption. So suppose I'm asking this question to all of you. If I want to increase the speed of a circuit, what should I increase?
The frequency.
The frequency, the clock frequency. Dedicatedly, you can see, say the clock frequency. Got it?
Yes, yes, sir.
But
Yes, sir.
we cannot increase it too much. It cannot be too much that you have 100 gigahertz of clock frequency running. Can you? No, right? The reason for that is if you will increase the clock frequency, what will be increased?
The power consuming,
The
sir.
power consumption and temperature will get increased of your chip. Your chip will get heated soon, and that might cause the circuit breakdown. Correct? So
Yes.
suppose if anyone asks you if the temperature of your chip is getting higher, how you will control it? How you will control it? If the temperature is getting higher, how you will control it? By reducing the clock frequency. Okay. So usually people ask that why can't we, because speed of the circuit depends on the clock. So why can't we have a more clock? Why can't we increase the frequency of a clock to make the circuit faster? Due to the constraint of power. If the power is getting too much, then your circuit might break down. Got me? So that's why we have thermal sensors, temperature sensors, we have PLLs. PLL is for the clock, generating the clock. Thermal sensors and temperature sensors are analog modules that are present inside every chip that sense the power consumption of a chip, that sense the temperature of a chip. Got it? Okay. Since they are analog modules, so what we have in our simulation, we use the Verilog model of them. What we use? Verilog model of them. So same like all other module, take an example suppose of PLLs. If I take an example of PLL, I काम करता क्लास कौन सी अपनी okay. Okay, so this is the suppose a PLL module. So same like all other modules, this is also an IP. Okay, and it will also have what it will have? It will have a config space, and it will have a, it don't have a data space, it's only have a config space because it generates clocks. This is the register. You can access this register just like any other IP through APB, and the clocks will be the output. The output of these blocks are the asynchronous signals of clock. Okay. The asynchronous signals of clock. Okay, guys. So what we do, usually these are the analog models. What we do, we just replace these analog modules by Verilog modules. Okay, that's it for the analog module. And it also have the registers. You will program the register to control the clocks. Got it?
Yes, sir.
Yes, sir.
Can
Yes,
you-
sir.
Yeah.
Yes, sir.
So I will paste that in our WhatsApp group. So suppose if anyone asks you, how do you verify the Verilog, the analog models in your SOC? What answer you will give?
reply the analog module by analog?
Yeah, we used to have Verilog modules of those analog modules, and it have an APB interface to read the registers of them. Okay, basically we call them behavioral models. Analog Verilog behavioral model. They will behave same like the analog model. Okay, I will type it over here. Behavioral model. Spelling behavioral model. Okay. Okay, guys. So it's a very easy. I mean, how you will verify the analog macros using the Verilog model of them. Okay. Okay. Now I will take you to the verification flow. I mean, this everything is clear to you guys, right? Now you won't face any problem in that. Okay, let's take one more example of SOC. We'll have a knock in between. Shri Charan, it's not mandatory. If you want to join, then you can. Otherwise, you can leave. No issues. It's just if you want to take knowledge. Okay.
Okay, sir.
It's not mandatory to join this. Just if you want to have any knowledge or anything like that. Okay.
Okay, sir.
हरिओम जया वगैरह को भी बोलो ज्वाइन करने को एक बार. बाकी जितनों को भी बोल रहा हूँ बोल दो. वेरिफिकेशन फ्लो स्टार्ट करेंगे तो आपको कुछ समझ में आएगा. ओके गाइस. Yeah, guys. So can anyone explain me? I have drawn this beautiful diagram. Can anyone explain me how does this SoC power ups? This is a multi-core CPU. This is a PCIe. This is a DMA. This is a NOC, IO pad. All the low-speed peripherals like SPI, UART, I3C, I2C will be connected to this bridge. There will be an SRAM, DDR, Ethernet. There will be a PLL block. So this PLL will have the config space addressed from this NOC, and it also have this asynchronous connection between all the IPs. Basically, PLL used to generate clocks, right? So the output of the PLL is directly connected to all these peripherals. Okay, and there is one more block. There is one more block called boot manager. We already discussed about it, right? We already discussed about the boot manager.
Yes, yes, we did, sir.
Yeah. So boot manager, just like the PLLs, boot manager also have direct connection of resets to all the blocks, right? It have a connection between with the NOC, and it also have a connection, asynchronous connection between all other SoC blocks. Got it? So this is a typical SoC architecture if you will be studying or looking into any kind of an SoC. Okay. So can anyone explain me how does we power on this SoC? Any one of you can explain me? If I want to power on this SoC, I will do?
So we will put the power button, and then the boot manager will send the wake up signal to all the module. To wake up all the module out of the reset statement.
Okay, then
It will receive the signal that every module had wake up, and they will start clock to all the module.
clock to the module. Okay.
That's
Shall I? So for ease, actually, shall I? So this diagram is clear to all of you, all the guys from India and from Vietnam.
Yes, sir.
Yes, sir.
Yes, sir.
Every one of you understand this. These are the basic building blocks of an SoC. Okay. These are very basic blocks of an SoC. It can have a NOC. It have a low speed peripherals that are connected at the bottom and everywhere. Okay. So shall I start writing the flow? So it would be much more easy and documented for all of you, right? SoC design flow. This can be like this. Okay. So I mean, you can use as a reference every time. Let's start. The first thing is power on. What you will do? You will power on the SoC. Okay. The second thing you will do is after powering on the SoC, you will bring the cold reset. Cold reset is basically through IO pad. Okay. From the outside world, we'll just press this cold reset button. Suppose this is a cold reset button. We will just press it out. Okay. This is the outside world. We will just press the cold reset button. Okay. What will happen after pressing the cold reset button? The third thing is reference clock will start. What is the frequency of the reference clock? It is typically what we can say very slow. For example, 50 megahertz I have taken over here. Okay. Up till this point, anything is unclear to you? We do have a crystal oscillator present inside every, you know about crystal oscillator that is used for generating the clock frequency. So it generates a reference clock of 50 megahertz. Okay. We will power on the SoC. We will bring the SoC out of the cold reset. We will, I mean, these 2 points are or more specifically, if I shall write it like this, when you will power on the SOC, reference clock will start for boot manager, and then you will just bring the SOC out of cold reset. So reset assertion will be synchronous. Okay. Then what you will do? You will sample the straps. We discussed about strap pins. Straps are nothing but GPIOs that are dedicatedly used. Straps are nothing but IO that are dedicatedly used during power up to decide where to boot from. Is it visible, or shall I increase the font? I will increase the font. Okay, now it's visible, I think. Okay, am I audible?
Yes, sir.
Yeah. So powering on the SOC, reference clock will start. We will just press the cold reset button. After the cold reset button, we have utilized some of the IO pads to decide where we need to boot from where we need to take the boot code of SOC. And like what I've already explained you guys, booting is of two types. Boot up is of two types. Either we can boot, okay, let's talk about SOC and CPU. The boot up is of two types. One is of SOC boot up and one is the CPU that is connected at the top. You can see the multi-core CPU over there. Okay. So in SOC, talking about now SOC boot up, what happens in SOC boot up? So the first thing that will happen in the SOC boot up, which components wakes up first? Boot manager wakes up first. Okay. When you will just press the cold reset button, which component will boot up first? The boot manager. Okay. Boot manager wakes up first, and depending upon the strap, okay, boot manager wakes up first, and it's the responsibility of the boot manager to bring all IP out of reset. Okay. Bring all IP out of reset. Boot manager waked up, you have sampled the straps. Then after the strap sampling, you have brought all the IPs out of reset. Now you are sure that all the components are working on which clock? The reference clock that is already been started, and all the components are out of reset. Okay. So my question is, can anyone tell me boot manager is connected to which reset? Boot manager is connected to
Or yes, reference cold. No, sir. Reference clock.
no reset. Which reset I'm talking about?
To the outside world reset.
The cold reset, right?
So reset.
Boot manager is connected to the cold reset because you are just pressing the cold reset button. Suppose this is the cold reset button. So boot manager is directly connected to this IO pad, and IO pad is connected to the boot manager reset. So when you will just press the cold reset button, boot manager will be out of reset. Since we have the reference clock running on all the modules, now boot manager will bring all the units out of reset. Okay. So now you can see directly over here, boot manager also have a direct connection between all the IPs. Boot manager has a direct connection between all the IPs. This one, this is the SOC reset. You see it? Just like the PLL. So these are the asynchronous connections. Asynchronous connections are directly connected. I will draw with some dark line, red line. You see, all the red lines are nothing but, okay, Okay, and all these lines are the clock lines. This is the red line. This is the red line. This PLL is the yellow line. Okay. So who will bring all the IPs out of reset? Who will bring all the IPs out of reset? My question.
Boot manager.
Boot manager.
Boot manager. Boot manager will bring all the IPs out of reset. Now your SOC is working at this point on which clock?
Reference.
Reference clock. You guys are understanding? You are with me? Anything is unclear? Anything is unclear? I'm asking. If you just want to be on mute, don't join the meeting. You can leave. It should be a two-way communication. There are a
So
lot of
for the PL, when we need to configure the frequency of clock of each module.
when you need to configure the frequency of this module, I will let you know. But currently, the frequency at which the SOC is working is 50 megahertz. Okay,
Yeah.
you got it?
Yes, yes.
Okay. So boot manager will bring all the IPs out of reset. Moving it further, now you need to boot up the SOC. Booting up, what does the booting up means? Booting up means you will have some default configuration on which the SOC IPs work on. Okay, you will have some default configurations on which the SOC's IPs work on. This is the basic meaning of a boot up. I'm talking about SOC boot up. We are discussing about SOC boot up. Okay, I think you guys are with me. So we were discussing about this SOC boot up. So booting up can happen from internal ROM or external memory. Got it? So there might be an internal ROM. For an example, this is the ROM that I have connected. Right, it's coming in between. I will make it small. A very tiny ROM that is connected over here. Near to the boot manager in this color. Okay, this is a, we can tell it is a boot ROM. So this boot ROM will have all the APB addresses of the IPs that it need to communicate or it need to program. Okay. What is this? What is this? Okay. So boot up can happen from 2 points. One is from the internal ROM and one is through the external memory. Okay. What does the boot code contains? It contains the address, or we can write the APB address of registers and the value to be written. Value to be written. Okay. So we talked about all the IPs. All the IPs have an APB address and a data space. So basically we program the registers. So there are some default configuration that we need to program. So what does the boot code contains? It contains the APB address of registers. Okay. and values to be written on them. All the registers width is typically how many bits? The
Any
register
32, 64.
32 bits.
Yeah.
32 bits, not 64. 32. We discussed, right? You forgot during your holidays. You see, I've written registers are of
32 bit.
32 bit. Up till now, anything is unclear? Okay. It also contains the data to be written on memory. Example, ARM boot code, PCI 5 firmware, etc. There can be a firmware of many things. So up till now, anything is unclear. What does the boot code contains? You can say the boot up can happen from internal memory or from some external memory. Boot code contains the APB addresses of the IPs, basically 32-bit data that need to be written for enabling them or for the basic functionalities of the IP. Boot code also contains the data that need to be written on the SRAM for ARM boot up and PCI 5 firmware and for the PCI 5 firmware. Okay. So let's review it again. Let's start. So the first thing will happen, you will just power on the supply. After powering on the supply, you will just wait for power to be stable. Power on the sock and wait it to be stable. Okay. Reference clock will start. You will press the cold reset button. After pressing the cold reset button, which module will sense the reset first? Boot manager. Boot manager will sense the reset first. Now the duty of the boot manager is to sample the straps. The straps would be sampled, that whether I need to boot internally or externally. So that type of values are stored in the strap. Okay. Okay. Which values need to be written? Or where we need to boot from? Booting can be from the boot ROM, the internal boot ROM, or from the external memory. The external okay. And what does the boot code contain? The boot code contain the APB address of the registers, the value to be written, and data on the SRAM, basically the AXI data of 64-bit or 128-bit data that need to be written to the SRAM. That basically contains the ARM boot code or PCI firmware, 5 firmware SRAM. Okay. PCI 5 firmware that need to be stored in the SRAM. So this is the typical booting. So like what we said, internal booting. So booting choice is from strap. That from where we are booting. Booting can be done from internally or externally. Internally, then it is done from boot ROM. Boot ROM. ROM means, can anyone tell me what do you mean by ROM? What do you mean by ROM? No one knows.
We can't
What is the full form of ROM?
read only
Read
memory.
only memory.
Read only memory. So basically we can only read through it. We cannot write it. Okay. So when the chip is fabricated, this boot ROM content is being stored in it. Okay. During fabrication, the content of the boot ROM is stored and that is fixed. We cannot change it lately. Okay. So this is internal. If we want to boot externally, then externally it will be from, it can be from SPI, it can be from I2C, it can be from USB, it can be from eMMC, it can be from SD card, it can be from any more example, it can be from SSD. etc. Okay. So all these components, SPI, I2C, those everything is connected through the IO pad. So we basically load the boot code inside these devices that can be programmed in real time, and we tell the boot manager to start booting from these. Like what you all have laptops and desktop, right? You all guys have desktop and laptops, or you don't have? Vietnam guys, Vietnam, Nam, Nahat.
Yes, sir. We have laptop
You
and
have. And what happens when your laptop suddenly shuts down or your Windows get corrupted? You usually
uh,
connect a pen drive, right, to boot your system. Correct? So
Yes,
that
sir.
is the
yes.
external booting. That is the external booting you are doing. Okay. And suppose if you want to enhance the operating system, you have a window, suppose 2008 installed, or okay, or window 9 or window 10 has been installed, and there is a new version of Windows 11. How you will install it? You will just install it either through the disk drive or through the USB, right? Like what we are just booting up the SoC, or enhancing the operating system of an the laptop, and laptop is also an SoC. So externally we can either boot from SPI, I2C, USB, eMMC, SD card, SSD, etc. So externally we can boot it. Internally we can boot it through boot ROM, but the content of the boot ROM is not changed. They are stored at during the time of fabrication. Anything is unclear? Any questions you have? Any questions anyone have? Okay, now let's move
Yes,
further.
okay, sir.
I will be taking your mock interview tomorrow, so you will be able to answer all of this. Okay. If any doubts, you can ask now. Okay. So after successful booting is done. Boot manager, typically what I can say, not always, typically brings CPU. CPU is basically ARM or any etc. out of software reset. Okay. There are two type of reset. One is the hard reset. So boot manager have already brought this IP out of reset, but asserting this hard reset or the wire reset. There is one more register inside the CPU called software reset register. We typically used to write a value of 1 to it that will bring the CPU out of reset. Okay. And there is one register. Usually, many times it has been asked, reset vector address register. Okay. This reset vector address register contains the address of memory where the boot code is stored. Okay. This question has been asked several times in the interview. Several times they have asked it. Who will decide the CPU will out of reset? It's the boot manager will bring CPU out of reset from wire and using the software configuration. After that, it will program which register? It will program the reset vector address register that contains the address of the location where the boot code is stored. So where we have stored the boot code, suppose inside the SRAM. We have copied the boot code inside the SRAM. I have written ARM boot code, PCI find firmware, data to be written on the memory. So which address this reset vector address register will contain? The address of the SRAM. Okay. And typical size of or width of this register is not 32-bit. It is 64-bit. Typical. Okay. Reset vector address ka width. So the width of the reset vector address is register is 64-bit. So now ARM will just jump into this SRAM and start fetching the code. Okay. ARM boot code. It will start fetching the code. So can anyone tell me how the processor work? So ARM will fetch the code from SRAM, basically memory, where you have stored the boot code. Okay. So the first thing, how does the processor work? It do the instruction fetch, decode, and after decoding, what it'll do? Execute. It will execute the instruction. Okay. ARM boot code typically contains PLL programming. PLL programming will be done by ARM basically. That okay, program the PLLs to the higher frequency, because up till now everything is working on which clock? Up till now everything is working on the reference clock. The reference clock. So now ARM will go in inside the ARM code. We just write boot code typically contains. I will make default ARM configuration on which the CPU will work. All the basic XI attributes. ARM code contains PLL programming or DDR, HBM initialization. Sorry, HBM init. It also can contain, ARM code can contain PCI link up code, okay, etc. These all contains. And then user defined code. It also has this user defined code, that what functionality you need to perform. So this is the full boot up process of an SoC. Now, any doubt, anyone, any questions? Because this is what I can say, the easiest way I can explain you the SoC power up. This is the easiest way we can discuss the SoC power up. Now I think it's more clear. Any doubt anyone have?
I'm reading it, sir. I'm reading it.
You are reading it, read it again, okay?
Yes, sir.
So all the guys from India, Hariom, now it's clear.
Yes, sir.
कल जो क्वेश्चन सर ने पूछे थे, now you will be able to answer all of them.
Yes.
संजीव is
हाँ,
here,
sir.
right? समझ में
Yes,
आया?
sir.
Anything you
हाँ,
are
sir.
getting?
सर इसमें मेरा एक डाउट है.
1 minute संजीव, कर सबसे पूछना डाउट्स फिर लेता हूँ. यशपाल, are you here with me? You're getting it?
Yes, sir. Okay.
Prajwal, you're getting something?
yes.
Jaya, you're getting something?
Yes, sir.
Akshay?
Yes, sir.
Okay, guys. So this is the typical SoC booting, what I can say. Now, Sanjeev, your question, बताओ, पूछो.
सर आपने ये बात बताया, as you think said that boot up happen of all IP on that reference clock.
Boot up, not bring up, what I can say. Not all
Okay,
the
bring.
IPs are prior to it. All the initializations and everything. This is all IP boot up. All IP are initialized during this time, and prior to it, it already programmed PLLs. I have written it somewhere, right?
Sir, I have a doubt like that. If any other IP working on different frequency, how we are going to bring up at the time of boot up?
At the time of boot up, we are not programming the IPs. I have told you, right? We are not programming the IPs. You see, first of all, let's revise it again, and I think your doubt will be cleared. Power on the SoC, weighted to be stable. All the IPs are working on 50 megahertz. Cold reset, we are pressing the button. Okay. Now, boot manager will start. It will sample the strap. Basically, sampling the strap means it will decide from where I need to take the boot code from. Okay.
Okay.
Boot up is of two types, basically internal or externally. internal is from the boot ROM and external is from these, I mean, where it is? Okay. This I2C, SPI, USB, eMMC, SD card, SSD, etc. Okay. So this all things will be the part of that. So it will just load the boot code from the external device and will store it inside the SRAM, or will store it and it will just program the IPs to work on the reference clock frequency. Okay. Usually, Sanjeev, during boot up, we don't program the DDR or HBM that needs some different or specific clock. Okay. Boot up means very basic configuration just to start the SoC. Then what will have? It will just bring the ARM boot code from external flash to the SRAM. It will bring ARM out of software reset and it program its reset vector address to start fetching code from the SRAM. Okay. Now, what does the ARM boot code contains? After successful booting, it means the boot manager typically brings CPU ARM out of software reset. Reset vector address, usually 64-bit. It contains the address of memory from where the boot code is stored. ARM will fetch the code from SRAM. Now, how? Basically, this is the program. How does the processor works? Instruction fetch, it decodes and it executes. ARM boot code typically contains the internal configuration of the ARM. The ARM internal configuration, it means the maximum X length it should support, whether the cacheable transaction is supported, whether exclusive transactions are supported, what should be the IDs that need to be sent if the transaction is initiated from CPU, all those kind of things. Okay. ARM code also contains, Sanjeev, the first things I have written, PLL programming. So ARM will go and program the PLLs. I have written it over here, right? And will bring each PLLs. I mean, there will be a separate PLL for DDR, for PCI, for HBM, for USB, for Ethernet, etc. So it will just go and program the PLLs. Okay. And it will, after the PLL will programming, it will initialize the DDR, it will initialize the HBM, it will initialize the PCI, depending upon on which, link up should happen on which gen basically. So this is a typical SoC power up. Shall I paste this? I will paste this in our SoC training group and also the UCI group. So this is the SoC training group I have pushed on. And where is the UCI group? I think this will help you guys. And this is a typical SoC architecture diagram that I have drawn for you. Okay. So moving it further now.
Sir, all these steps are part of SoC boot up only, right? After this, the CPU boot up will start.
I have already explained about CPU boot up over here. After successful booting means boot manager, this is done. Bring ARM out of reset and goes to idle. Okay. Now it's the duty of ARM to start fetching the code. Now this part that I have written, right? This is ARM booting. What code does ARM contain?
So ARM only have software reset.
Yeah. Yeah, man. You are asking something?
No, I asked that the ARM only have software reset. Right, sir. It only have software reset.
Which software reset? ARM.
Yes.
No. You see these wires are connected, right? Boot manager wire reset is there. That will bring the ARM out of reset. But to start its functionality, we need to bring it out of software reset. So typically there is a register. We used to write a value of 1. Basically active lows register is there. We just need to write a value of 1 that will bring that out of reset. Okay.
Okay, sir.
हरिओम यशपाल क्लियर हुआ थोड़ा सा?
Yes, sir. Yes, sir.
हाँ जी सर काफी
अब कल के जो क्वेश्चन थे आप आंसर कर पाओगे?
Yes, sir. Yes, sir.
Yes, Sricharan, anything you want to ask?
Yes, sir. Sir, all cores in a multi-core CPU will boot
No,
up parallelly or it will
no.
happen serially?
One core will boot up. I will write it down over here. Okay. Typically, one CPU core boot ups. Okay, and then it will bring other cores out of reset.
Same sequencer or it's
It depends. It depends. Suppose if we want one core to be supporting AX length up to 8 or bufferable transaction, cacheable transaction, all those kind of stuff. So it depends on what type of boot code you want to or what configurations you want to have for this other core. It totally depends on you.
I mean software driven or hardware driven?
Software given, hardware given is nothing. Everything is software driven. Since one core is out of reset, now you have full control over the SOC. Now you have full control over the SOC. So that core can go and one core can bring up other cores and can bring any of the IP, program any of the IP, program the PLLs for any of the frequency and anything.
Okay, sir.
Okay. So questions for Vietnam guys. Are you ready? Vietnam guys.
Yes, sir.
Yes, sir.
So Nam, you have to prove yourself in front of Indian people. Okay, answer the question. We talked about DMA that day, right?
Yes, sir.
So can you just describe me the functionality of the DMA? If you want to enable the DMA, what things you will do?
I will send DMA the its direct message asset. So to the DMA, I will it to only use for transferring the data from input or output of the device. So I will send it the data and the address of the register for it to transfer it, sir.
Okay, you will program the register for the source address, the destination address, and the amount of data, right?
Yes.
And then you will enable the DMA, right? And when the DMA transfer will complete, how it will inform the CPU through?
It will send the interrupt
Interrupt.
when I send to the DMI the address, the data and the address, it will go to the interrupt to reset it, and when it done, it will out the interrupt.
Okay, okay, it will just go on the interrupt and interrupt tells that whether the data is completed successfully or not completed successfully.
Yes, sir. And it
And
will have the signal to tell that if the address is valid or not.
yeah, address is valid or not. Okay.
Yes, sir. That as far as I remember and understanding, sir.
Okay. Okay, good. So, any questions, anyone? Or shall we continue? So, typically, I think if you understood these things, I mean, basic concepts of SOC is clear to you. Basic concept of SOC is clear to you if you are able to understand what I'm trying to explain you. Okay?
Yes, sir. Yes, sir.
Okay. In tomorrow class, I will paste the new one basically. I will just delete this one. And I will paste the new one. And same for the UCI group. Okay. So you guys enjoyed the training part? I mean, is it interesting or you got bored? Everyone?
Very interesting, sir.
Yeah, Dat. I will ask from Dat first. Dat, you got the idea?
Yes, sir. It's good.
So it's interesting. You able to grab something? You learned something new?
Yes, sir. I learn it. It's good. Sir.
Okay. So in tomorrow class, that you will be explaining the full flow. Okay.
Can you repeat, sir?
That in tomorrow class you will be explaining the SOC design flow. Okay.
Yes, sir.
And Nahat, same thing for you. Okay. Nam,
I think
man,
it's okay, sir.
Nam and man, same thing for
Yeah,
you.
yeah. Yes,
I
sir.
will be
Yes.
asking questions and you will be explaining me the flow. Okay.
Okay, sir.
Man,
yeah.
are you getting?
Yes, sir.
Are you getting?
Yeah, I know.
Okay, man. Okay, guys. So I'm just sharing you the code. Basically, I have a very beautiful code of C. So tomorrow I will be discussing about C code and everything. So man, okay, this is the example C code. You guys have, I think, I don't know whether you guys have or not. I will store it in some kind of a TXT file. Okay. Copy and I will share it to you guys. So just go through this C code first as well, how to write a C code. So you will get a very good idea. When you will come in tomorrow's class, you will be understanding about the C code. I've shared this C code. It's not here. 1 minute. Where is the WhatsApp? Yeah. Have I? Okay, here this one. SOC training. Desktop. This is the C code. Okay, guys. So I have shared a C code TXT file with you. Just go through it. It's an important. Okay. How to write a C code? You will get a basic idea. Tomorrow I will explain you everything.
Okay, sir. Thank
Yes,
you,
sir.
sir.
And everything is written actually, the flow and everything. So you should get an good idea about that. Okay. Now this is how does these functions. Kushal, कल आपसे एक क्वेश्चन पूछा था ना, ये कुछ
Which one, sir?
this ये वाला. The functions that are mentioned, write CFG, read CFG, pointer वाला कि कैसे write करते हो. How does these functions are written? So ये है उनका कोड भी, ठीक है.
Okay, sir.
मैंने WhatsApp किया है अपने ग्रुप पे. And same
Yes,
thing,
sir.
Vietnam guys, I've also shared that code to you as well. Okay.
Okay, sir. I see it, sir.
So let's revise it once. Okay. I will just go to the top where we started our class. This diagram is clear. Then we started about the address map. I described you about the IP, that IP of the config space and the data space. Okay. Data space. Then you just calculated the memory space and the config space. Got it? How do you verify the IP at block level? How you connect the VIP? Then we moved a bit over here. We described about the access rights of the register, read only, write only, everything. Then we talked about this, how the NOC communicates to the IP through APB and AXI. Okay. We also talked about the registers, how it is connected to the IP. We talked about GPIOs, how the GPIO is connected, how the register is there. GPIOs of 16 pins basically. And let's move here. We talked about DMA engine, how the DMA engine works, what we need to program, and how the things worked on, right? So just go through all the figures that I already sent you to the Vietnam guys on the group. And if India guys need it, I'll send you separately. If you need it, then ping me, okay? So, I mean, this is today's class. I've already shared it with you. I think this is the best that I can do to explain you guys, since you are sitting far away from us. So just go through it. Try to utilize also your knowledge into it. try to connect it with the real-time scenarios, that how the things works on. Okay, and then you will be able to answer something more better if they ask you something. And in tomorrow class, I will just ask some questions to you regarding the boot up and the power up that we shared. And what I'll do, I will just tomorrow we will be completing the topic number 6, 7, 8, 9. How the SOC test plan been created, how the environment is being created, how the C environment is set up, how and C and SV interact. So this will be an important class for tomorrow, okay? Because since you didn't have class from last 3 days and you are from vacation, so I just revised everything what we talked about during the last week. Okay, so I think that's all for today. Any question, if anyone have, they can ask. Any questions from anyone? Jaya, you got everything?
No, sir.
Okay. Jaya, you got everything? If they will ask you, Jaya is here.
Yes, sir. I'll try to answer.
Hariom, Yashpal, Naginder.
As of now,
Okay, guys. Hope it's not boring and you understood something. Okay, guys. Thank you. Tomorrow 10:30 same time we'll meet. Tomorrow 10:30 same time. Okay. And Vietnam people, since now holidays are over, try to go through the try to read something. I'll share the CV with you, Vietnam guys. Okay. Thank you. Bye.
Thank you, sir. Bye-bye, sir.
Thank you, sir. Thank you, sir.
Thank you.
Yeah, bye bye.
Thank you.